Hello friends, welcome back to our channel. In this video, we are going to see how to set up a basic NFS server and NFS client in a Ubuntu operating system. Before setting up NFS server and client, let us understand what is NFS. NFS is Network File System. It's a protocol using which we can share the files in one machine to other machines. For example, if you have an application which may run in multiple machines like machine 1, machine 2 and machine 3, and if you want to share some data which is residing in the server to other machines, we can set up the NFS server in this machine. This NFS protocol will allow us to share the data in one or more directories of this server to other machines. So to perform the basic NFS server and NFS client configurations, we have to perform several steps. First, in the server machine, we have to install the NFS server component, and then we need to update the required NFS configuration files to contain the required directories in which corresponding files will be shared with other machines. Then in the client machines, we need to install the NFS client components. After that, we need to mount the corresponding directories from the server to other client machines. For example, /var/NFS directory in the NFS server will be mounted on /opt/share in the client 1 machine. We can also mount the same directory to corresponding directory in the client 2 machine as well. So these directories can be same or different based on our application requirements. While sharing this directory to other machines, we can configure various options. So let us discuss about these options one by one. There are other options as well. Here I have mentioned the most frequently used options while configuring the NFS configurations in the server. So the first option is read write or read only. So this option allows the clients either read write or read-only permission on the corresponding directory in the server. If we provide RW option, that means the clients can read and write to this file system. If we provide RO option, that means the clients can only read the data from the NFS share. The next option is sync or async. So this sync option will be used for data integrity. That means whatever data the clients are writing to the share will be saved to the disk before sharing with the clients. For example, if we share a directory /var/NFS to the client 1 machine by mounting on this directory. So if the client 1 performs a write on this directory, then the request will go to the server. The server will write the data to this directory before replying back to the client. That means this sync option will ensure the data is written to the disk before the response is sent to the client 1 machine. This way, the sync option will make sure the correct data will be read by the clients. We can also use async option to make these writes faster. So using this option, the server will keep the writes in the cache directory in the server. It will reply back to the clients from the data in the cache, and the server will write the data to the disk asynchronously. The problem with this async option is if any crash occurs in the server and if the data is not written to the disk from the cache, we may lose that data. The next option is root squash or no root squash. The root squash option is the default one. This option will make sure the root users on the client machine will not have corresponding root privileges on this shared directory in the server. So by default, the root users on the client machine cannot perform the root operations on the shared directory in the server. So this NFS server will treat the root users as nobody by default. But if we want to allow the root privileges for the root users in other machines to the shared directory, then we have to use no root squash option. But we have to use this option with care because the root users will have full access on this shared directory. The next option is subtree check or no subtree check. Using subtree check option, the NFS server will ensure the clients access the correct directories of the shared file system. So if the clients perform some operations on the directories, then the NFS server will check corresponding directory is really a subdirectory of the shared file system. So these checks will happen every time. This may slow down corresponding NFS operations. So to avoid the slowdown, we can use no subtree check option. So let us perform all these steps in the demo. Let us start with installing the server component as well as client components. Here I have two machines. This host will be used as NFS server and this host will be used as NFS client. Both are having Ubuntu operating system. Let us try to install the server component here. So before that, we need to update the index. So we have updated the package list. Now let's install the server component. For server component, we need to install a package called NFS kernel server. The package is successfully installed. Now in the client machine, let's install the client component. Before that, let us update the package list. The package list is updated. Now let us install the client component. For this, we need to install a package called NFS Common. NFS Common package is successfully installed. Now we have installed the server component in the server host and the client component in one of the clients. Now let's create a directory in the NFS server and we'll configure that in the exports file of NFS server so that this directory can be shared with other clients. As part of that, we'll see various options which are mentioned earlier. So let's create a directory. The directory is created. Now let us open the exports configuration file and we'll configure this directory. So here we can see some examples how a new directory can be shared. First we need to mention the directory and then we need to mention the host name or the IP address of the client machine to which we are sharing this directory. So let us get the IP address of the client machine. This is the IP address and then we need to provide the required options. So initially let us provide all these three options: read write, sync and no subtree check. So this means the client will be able to read and write in this directory once it is exported to outside, and also the data will be synced to the disk as and when the write operations are performed on this directory and before sending the response to clients. And the option no subtree check will make sure the subdirectory of this directory will not be checked every time when corresponding operations are performed on this directory. So let us save this configuration now. The file is saved. Now let us apply this configuration. The configuration is applied by using export fs command. Now in the client machine, we need to mount this directory. So let us create this directory in the client and we'll mount on this directory. We can use the naming conventions for the directories as per our project guidelines. Here I am creating this directory. So let us mount now. So for mounting the share from the NFS server, we need to mention the IP address or host name of the NFS server. This is the IP address of NFS server and the directory is var NFS, and we'll mount on this directory. So let us execute this command. Now the directory is mounted. We can verify this by using df command. Here we can see the var NFS directory from the NFS host is mounted on /opt/share directory on this client machine. So let's go inside this opt share directory. Here we can see there are no files in this directory. Let's try to create a file in this directory. Here we have got the permission error while creating the file. So let us see the permissions of this directory. Here this directory is owned by root. Still we are not able to create the file. That means there should be some setting in the NFS server. So let's go and check in the NFS server. So let's go inside var NFS directory. Here let us check the permissions. Here if you see, it is owned by root in the NFS server. But by default, the NFS server will treat the root users of the clients as nobody. That means the root users of clients cannot write to this directory. So if you want to allow other users to write to this directory without giving other permissions, we need to change the ownership of this directory to nobody, because the server will treat the root users of other machines as nobody. So let us change the permissions. So here the group is wrong. The group is no group. Now we have changed the ownership to nobody. Let us verify the permissions again. Now it is owned by nobody. Now let us go to client and try to create the file again. Now we can see the file is created successfully. Let us check the files here. Here we can see this file is owned by nobody. So this happens because by default the setting is root squash. That means the root users of other machines will be treated as nobody in the NFS server. But if we want to allow corresponding root privileges in other machines other than NFS server, we can use no root squash option. So let us try to do that now. So let us open the exports file again. So in addition to these options, now I am providing no root squash option. So this option will make sure the root users or the client machines will have root privileges on the NFS share. So let us save this configuration. Now the file is saved. Let us apply this configuration by using export fs command. So this configuration is applied. Let us verify the permissions of this directory again. So this is owned by nobody and no group. So let us revert this permission to earlier root user. So now this directory is owned by root. So now let us go to the client machine and check whether we can create another file with the corresponding root user. Now the file is owned by root user. So let's try to create another file here. So here we can see we are able to create that file. And both the files are owned by root user. So this is because we have applied no root squash option for the share which is shared from the NFS server. Since this option will give the root privileges, we should be very careful while providing this option. So we have gone through various options of NFS export, and also we have seen how to mount that NFS share into the client. So earlier we have mounted using mount command. This mount command works temporarily. That means if the system is rebooted, we have to execute the mount command again. So to make this NFS mount permanent, we need to add an entry in a file called etc fstab. So let us open that file. So here we can add an entry. First we need to mention the server and the NFS share. Here I am mentioning the IP address. And the NFS share is var NFS. And here we need to mention the mount point in the client machine. Here we need to mention the type of the file system, which is NFS. And we have various options for NFS here. We can check that by using man NFS command. So I am using defaults option here. Then we need to add two more entries, 0 and 0 here. Here the first 0 tells the dump backup utility not to take backup of this mount point. And the second 0 indicates not to check this file system when the system is rebooted. So let us save this file configuration. Before saving this file, I have updated the directory to /opt/share, which is the correct directory. So let me save this file. So we can verify the file entries by using mount command again. This time it is sufficient to give -a, which will mount all the required directories based on the entries in etc fstab. So let's verify again. So this is the entry corresponding to NFS mount point. So the advantage of etc fstab entry is whenever we reboot the machine, automatically this NFS will be mounted on this local machine. So in this video, we have seen how to set up a basic NFS server and an NFS client in Ubuntu operating system. As part of this, we have seen how to set up the NFS server component and the client component. And then we have seen how to share a directory from NFS server to the client machine by using NFS protocol. As part of this sharing, we have seen various options which are mentioned here. So this is all about basic setup. I hope this video is useful. Thanks a lot for watching.